How does slenderness ratio prevent buckling failure? Have you ever wondered why some structures stand tall while others seem to collapse under pressure? One key factor is the slenderness ratio, which plays a vital role in preventing buckling failure. Let's break this down in simple terms. The slenderness ratio is the relationship between a column's effective length and its radius of gyration. The effective length is the distance between points where the column is supported. The radius of gyration relates to how the material is distributed around the central axis of the column. When the slenderness ratio is low, it means the column is short or has a cross-section that resists bending well. This makes it less likely to buckle under pressure. On the other hand, a high slenderness ratio indicates a long, thin column that is more susceptible to buckling when a compressive load is applied. Buckling happens suddenly when a compressive load causes the column to bend sideways. This can lead to failure at loads that are much lower than what the material can normally handle. The slenderness ratio directly affects the critical buckling load, which is the maximum load a column can support before buckling occurs. According to Euler's buckling theory, the critical load is inversely related to the square of the effective length. This means that as the effective length increases, the critical load decreases. The critical load is also directly related to the column's moment of inertia and the stiffness of the material, known as Young's modulus. Engineers can control the slenderness ratio through design choices. For example, they can shorten the unsupported length of a column, increase its cross-sectional area, or add lateral bracing. Each of these methods helps to reduce the slenderness ratio, which in turn increases the critical buckling load. Let's look at a practical example. In construction, long and slender columns are often reinforced by thickening them, adding braces, or using materials that are stiffer. This reduces the slenderness ratio and enhances the column's ability to resist buckling. If engineers do not manage the slenderness ratio properly, it can lead to serious failures. Historical examples show how neglecting this aspect has resulted in catastrophic collapses of structures. In essence, the slenderness ratio is a fundamental concept that helps engineers design stable columns. By understanding the relationship between a column's length and its cross-sectional geometry, they can create structures that remain safe and functional under compressive loads.